with Nancy Fresco, Dr. Nancy Fresco, from the Scenarios Network for Alaska and Arctic Planning. And we're here to have a discussion about models and models in climate change research. We hear about models in the newspaper, and we know that it's really important for climate change to understand climate change. There's a lot of misunderstanding, Nancy, in climate change communication about what models are, and it makes it sound a little scary. Like, what is it? It's math, definitely. Models are also really important in our national education standards right now. They are increasingly emphasized for students to learn. And so I invited you here today to demystify models in climate change research. What is a model, Nancy?
Well, the thing is, models might sound scary, but we're all using models already every day in our daily lives.
Yeah.
Your daughter's dinosaur, it's a model. Yeah. It's a model of the real thing.
Right.
It's what a model is a simplified version that includes parts or components of the real thing, of the real world version, but only the parts that are important or pertinent to what you want from it. With a model toy, you want certain aspects, but not all aspects of a dinosaur.
Right, we want to know the shape. And it's based on some observations that people made, data that people made. It's not just out of nowhere.
Right. Yeah. It's based on what we know about dinosaurs. So any model is a translation from the really complicated, messy real world that has tons more details than you actually need to the simplified version that can help you learn more about the real world by being simpler.
So maps are another kind of model, right? Maps. Here's a map that we have that SNAP produced that shows average temperatures across Alaska. Maps are another type of model, right? That we see every day.
Exactly, and we produce a lot of maps at SNAP. Yeah.
Okay, so Nancy, what you're saying is, I'm going to draw this out. Okay. In the style of my modeling professor, Dr. McGuire, he drew, here's the model, or the real world. This is our real world.
Right, it's messy.
It's really messy.
Lots of detail.
Complicated real world. And we're trying to describe it. And through our model.
That's right, and the model is
it's
smaller,
nice and clean, simplified so we can understand
tidy.
it. And
exactly.
You're saying that we're making it using the things that matter in a particular situation, right? So things that matter to a problem.
To the questions that you have, or to the purpose that you have, or to what you want to find out. And of course, the most important first step is gathering information from the real world so that you can put it into your model.
So you have this data. I've seen you try to tell the story of the three little bears using this data.
Exactly. And this is a great example that I like to use because when we tell stories, we like to include a lot of detail to make the story more interesting. But as modelers, we do the opposite. And this exemplifies how scientists think about the world. When you're talking about the three bears, you'd want to include all kinds of little details. But when you're trying to turn that into a model of the story, what really matters? You have the three bears, you have the porridge, you have Goldilocks, and maybe you don't need to know that Goldilocks' hair is blonde. Maybe you certainly don't need to know details about the woodland and about her shoe size and about the time of day. You bring it down to the essential details, and this is how scientists think.
Yeah. Okay. So back to our conceptual model. So the thing that you're using you figure out what things matter, and then you make observations of those things, and you're collecting data, just like in your example of the story.
Exactly.
All right. So So here's our data.
Yeah, and people can get intimidated when you say data because they immediately think numbers. But data, it's just information. It's what you see, what you observe, what you know about the real world. And that includes basic information, it includes numbers, it includes everything about the real world. This is what you know.
Okay. So Nancy, I think a lot of people they can get, data, I can understand that. And especially in our Arctic and our science community, where we have volunteers and students that are actually out collecting data, people can understand that because they can do it, right? And then and the more data we have, the better that this data can represent the real world. Which is why one of the reasons why we as citizens collecting data and students collecting data can really make an impact with our work that we're doing. how people get scared though, Nancy. How do you get from the data to the model? Yikes.
Okay, well, just as an example, say you had information that you'd collected from observations. Imagine you had a greenhouse and you're growing some plants in your greenhouse, and you notice that as you change the temperature of your greenhouse, as it increases, you notice that the plants are growing more. They're getting bigger, so you have more growth. And the reason you feel that you know this is you have this information. You've taken measurements and you see this pattern, and you say, wow, that looks like a pattern that I could learn something from. I'm imagining that there's a relationship like this. And then in your model, you say, well, maybe that's what the relationship is.
Now, so that's like a line, right?
That's
so you can
just a simple line.
So you turn that into an equation that you learn in high school, right? Mm-hmm. Y equals the slope times x plus the intercept, right? So y equals mx plus v. You got an equation, okay?
You're starting with this model, and you're saying, okay, maybe my model is that growth increases with temperature. That's my model. But do you see a problem with what I've done with this model?
Oh boy, Nancy. Yeah.
Temperature is increasing.
If it gets super, super hot, if it's like 150 degrees, you're not going to still get more growth. Right. They're going to die.
And so this is when we get this really important step in modeling, which is when you take what the model is implying or telling you, and you check back with the real world. You check back with your data, and we call that validation. Right. Making sure your model is valid. When you do that step, you might find, okay, this relationship holds up to here, but then you get to this temperature, and all the plants die. And that is how you can keep your model honest through validation. And that's why you need to always be checking back with the real world, with the data.
You know, Nancy, that this really is another reason, in my view, of why students gathering data and citizen science projects, community monitoring is so important, because sometimes all scientists have is this data, and they can't get out here to collect this data or this data.
Right, and they know that they need this information, and they don't have it yet, and they rely on finding people
everywhere
to collect it for them.
Okay,
exactly.
So what you're doing with your students and in your community is so important for helping us understand climate change. Nancy, what are some of the uses that you at the Scenarios Network for Arctic and Alaska planning? What are you using models from, and how do you make them useful to communities to solve problems?
Well, really the first step in making any model useful as a problem-solving tool is to talk to the people that you're working with, to ask them questions, say, what do you care about? What matters to you? Because with climate change, you might hear someone saying, well, the average July temperatures are going to become 3 degrees warmer in the next 20 years. That might be a model that is correct, but it's not necessarily a model that's useful. That might not be what people want to know. But if you say the amount of Arctic sea ice over time has decreased by this amount, and we see a very obvious trend despite some variation, and then we say, does this matter to you in terms of shipping, in terms of ability to get out subsistence hunting, in terms of safety on the sea ice for people in a particular community? Those might be the questions people want answered. So figuring out what matters to people and how the data links to that matters tremendously, because a big part of modeling is to avoid including what you don't need.
Okay. Can you give us an example of that?
Oh, sure.
Okay.
I mean, I think a type of model that we're all familiar with and we all use all the time without thinking about the fact that it's a model is a map.
Okay.
You need to get to your friend Stella's house, and she's told you, well, go along Park Lane and turn right on Hubert Street. Okay, and you might look on Google Maps, and really, this is the information you need. It's simple. Yeah. It's not the real world. The real world is way more complicated. And adding more to this model would not necessarily help this model. If you knew that over here there are radio towers, and over here are the flight paths of jet airplanes, and here are the railroad tracks that are actually not near her house, this does not help you. In fact, this makes your model worse. And so there's often this feeling that a model should be as complicated that if you have information, you should throw it into your model. We use models. Maps are a great example. You want to have the information that you need, that's pertinent, that helps you make decisions, that helps you make projections about the future, and you don't want the whole kitchen sink.
Yeah. So it seems like when you're thinking about models, and especially like communicating what models mean in climate change research, you want to be sure that you know what models can do, but also what they can't do.
Yes,
right?
Exactly. And overstating or misrepresenting what a model can do, it doesn't help anyone. It doesn't help you as a scientist, and it doesn't help the public. But it also, there can be a model that is useful for one task and not for another. So, for example, the Nenana Ice Classic, something we're all familiar with. People put money in the betting pool, so it matters to them. So there's great data for over 100 years on exactly when the ice went out on the Nenana River. And as you can see, it's really variable over time. And having a model of that might not help you make, $100,000. Might not help you place your exact bet. But you can see that there's a very obvious trend toward the ice going out earlier. Yeah. And if you look at that data compared to the date when the leaves come out on the trees, or green up date, then you say, okay, this is a model that you could actually use for prediction. So depending on what you want to be able to predict, how you want to be able to predict it, knowing that one way or another is a tremendous help.
Yeah. Okay, Nancy, this is helping us not be as scared of models. So just to refresh, we know that the real world is messy, right? And that we use models in climate change to help us understand the world and help us plan, right?
Yeah.
And that we need data, which is why your students' data is so important and valuable, is that there to help represent this real world. We need that data. We know that you, as a modeler, as your profession, you are using that data to help explain patterns and help us predict and make sense of it, but you're also going back to the data always to make sure that it's still reflecting the real world.
Always validating, yeah.
And we know that models, the math involved is, you can understand it as a person if you know how to make a graph. And so teaching those sorts of skills to your student is super important for understanding modeling.
And keep it simple.
Yep, keep it simple. And then finally, we know that models are not crystal balls. They're good for some things, for the intended purposes, and not for others. And finally, Nancy, models are not scary.